So, hey everyone, we are starting in 1 second. And today I'll be talking about very interesting topic. And it will be about the places where I look for the issues. Because, usually when you are working with the project, the projects are pretty big. So, it will take a lot of time to check everything, and usually there's not enough time for that. So you need to correctly focus on only the most important parts. So I'll be telling what I learned in my last 3 years during audits and bug bounty, and we'll go over the top 10 places where I look for the issues. Okay, so a little intro about me. So I started hacking very late. Very early. When I was still in high school, I was already, finding my first issues. I started with Bitcoin very early. 10 years ago, I had like 200 Bitcoins, but I sold them for not so much. So it was interesting fact. And 3 years ago, I started working for Hacken as layer 1 auditor. During that period, I found like more than 70 critical issues, like, for example, in Binance proof of reserves, or for example, an issue which allowed, in theory, to steal $1.1 million from lending protocol. I was doing a presentation about that, a webinar 2 or 3 weeks ago. So, it's pretty interesting. I recommend to check. And this year I started to do bug bounty, and I managed to make it to top 3 on Hacken proof. But trust me, I will be top 1. They just need to update the ranking. It takes a lot of time, for some bugs to be paid, and so they can be included in the leaderboard. So yeah, that's me. Okay, so the most important thing, at least in my case, is that I usually think differently regarding the projects. I don't have the same approach with the software developers do. I usually have totally different point of view for the projects. So I will show you how I, as a cybersecurity expert, let's say, or hacker, I'm thinking we're working with the project. Because, doing cybersecurity is mostly about thinking out of the box, outside the box. So finding a way how to do something differently, the other way than the developers planned. It's usually not about just checking the code and searching if there's a mistake in the code, or if there was something coded incorrectly. It's more about thinking about those other ways which developer, engineer didn't think about, and then usually combining those ways, those small mistakes in different ways to create an issue. This is basically how I found most of the interesting issues in my career, by thinking out of the box. So yeah, let's go to the next page. Okay, so let's just go over this list, my top 10 of places where I look for the issues and the patterns. Okay, so let's start from top 10. And this will be the code which is ported from another platforms or languages. So in many cases, I've seen the code base where some code or some feature were ported from another language. Like, for example, some projects were migrating from C++ to Rust, or like in case of smart contracts, some Solidity to Rust, Solana, or Movement. And the thing is that even if code in one language or original language was audited, was checked, there were no issues, everything was perfect, then when you port it to a different language, there can end up in totally it can end up working totally different, because there are a lot of small differences between languages, between execution environments, which are easy to miss, and it's easy to make a mistake and don't do something correctly. For example, when it comes to porting like Solidity to move to a language, for example, the function execution cost of some function may be different, or for example, the storage limits can be different, and because of that, it may cause, for example, some denial of service issue, or maybe like SDK or functions are different. And so this is like one of the places where I start to look for the issues whenever I see something, especially that often, when someone was porting code which was already audited to another language, they don't audit it again, or they skip this process because they think, it was audited, it worked well in this language, so what could go wrong in this case? And it's usually leads to very interesting issues. So I managed to find a few issues like that by checking these parts of the code. Oh yeah, I have an example in case of the WebAssembly. So during one of the audit, they were having smart contracts in Rust, and one of the platforms was executing this smart contract in WebAssembly. But the difference, for example, when it comes to WebAssembly between like Solana and let's say other protocol, which is that WebAssembly is using 32-bit architecture, and Solana is using 64-bit architecture. So in this case, usize was behaving totally different, and by that, because they didn't think about this scenario, it was possible to cause integer overflow, and it allowed to create fake signatures. So this is a good example, which is usually hard to notice because it's a very small difference, like 32 bits for this 64 bits. What's the difference? But there is. Okay, next part is, of course, the code using algorithms. I mean, you can argue that everything is algorithm when it comes to programming, but I'm thinking more about complex algorithms, especially algorithms from third-party libraries. And for example, I had a case where which I found totally where I found a bug totally by chance, and it was when I was checking what's using CPU usage, what's using the most CPU when executing the transactions. I was using perf. This is a tool which allows you to see what is using the CPU. I was just running transaction, checking what's going on, and I noticed something very interesting. And it was that base 58 function was using like 1% of CPU. And that's a lot. I mean, usually from what I know, or from what I was thinking, is that base 58 has linear complexity, computation complexity. And it's true, but it's only true for base 64. And the thing is that in case of base 58, the complexity is not linear. The complexity is actually n squared. So the number of operation goes grows a lot with the number of the operations which can be done. And the developers also didn't know about this, that there is this difference in the complexity, and they started to use base 58 to encode transactions in the blockchain, because what's the difference, right? And yeah, the difference was huge. I mean, it was possible to abuse this, and by creating some specific transaction with a lot of data, it was possible to take down the network, because a transaction with 250,000 elements was taking 10 minutes to execute. So yeah, that was a very interesting issue. So yeah, when I see a project using a complex algorithms, especially with high complexity, not only computational complexity, but also memory complexity, I always check if there's any way to abuse it, maybe by generating some very large input, because not all the developers are thinking about the performance, and it allows me, the hacker, to find the issues. Oh yeah, and there's one interesting thing. I even try to verify if AI would be able to find this issue. I ask this, okay, is it safe to use base 58? And it wasn't able to correctly identify that base 58 is a problem and can be abused to cause denial of service attack. I even posted the exact code and tell how it's used. Back then I used O1 Pro model. I don't know what about the current models. You can give it a try. Just don't suggest the AI that it is an issue, because when you suggest something, then it's not exactly useful. I mean, the problem with AI is that you often can create this how to say it, fake scenario. Maybe not fake scenario, but if you suggest AI something, this is a behavior which is usually which you cannot reproduce in production environments. So just ask without giving any hint that there may be an issue, like I did. And maybe the current models would be able to answer this. I need to check. Okay. So the next part is the code on which multiple developers work together. So I mean, this is, I would say, classic place, because when there are multiple people working on something, it's very easy to make mistake, because the people I think and I are usually thinking differently, especially when the project is very complex, and and not all scenarios are tested, because at some point usually the code base is getting so large that it's impossible for a single developer to understand everything. So when one developer is implementing a new feature, they may by chance introduce some mistake in other feature, or use some other feature incorrectly. And there are some usually it's easy to notice that there are going to be some problems in this category. Like, for example, when I see inconsistent coding style, or there's unclear ownership, or feature over bug fix mindset, especially when team is in hurry and they introduce quickly new features, then don't introduce tests, it's a red flag, and I will be for sure checking the code for issues, because there's a very high chance there are going to be some issues. Okay, next thing. So recently updated code, especially old code. So yeah, a lot of teams are usually in hurry to introduce some changes, and they often do it without a lot of tests, without checking how it changes all the existing code so far. So it's a very good place to look for the issues. especially when I see that, something was in hurry, it wasn't deleted or something. This is an obvious place to check, especially that, when the code is updated, especially when the old code is updated, it's very easy to make a mistake in this old code interactions, because usually this old code was interacting with a lot of different components, and after some time, maybe it's already a different developer working on this, not the person who implemented the old code. Maybe then they don't know what was this function even doing back then, how it was interacting with other elements. So it's it's very easy to make a mistake. Okay, the next place, called interacting with third-party components. So yeah, I mean, when you are using third-party libraries, then it's very easy to make a mistake and use them incorrectly, and it especially applies to the cryptography. So yeah, because many developers assume by default that the other package library is safe. They usually don't do audit. Usually it's not part of the audit, even when something is audited, to verify dependencies. So I always check what those dependencies are, where are they used, how popular they are. If I see a project which is using some dependency which has 5 stars on a GitHub, it's a red flag. So for sure, I will be checking what are the interactions with that component. And if those interactions are dangerous, like cryptography or some complex algorithms, then I would be checking if maybe there's some bug or issue with this third-party dependency. Because trust me, there are often bugs in third-party dependencies, especially when you add to this that for some reason the people take those dependencies as secure by default. So yeah, it happens. Okay, the next part. This is one of the best ones. So a super red flag. When you have a project and you have some complex code or features and they don't have a test. Oh, this is perfect, because I have this way of thinking that if you are not able to test something, to write a test for something, then you shouldn't code it, because this means that you are not experienced enough to write such code in the first place. I mean, it doesn't apply to everything, but in my opinion, it applies to all the Web3 and blockchain projects. So, if you're a developer and, you don't know how to test something, then you shouldn't code it. I mean, of course, there are some exceptions to this rule, but usually you need to be at this expert level to use those exceptions. So yeah, so whenever I see something like this, like complex code, no test, this is a huge red flag, and I will be checking this code for sure, because it's I mean, it's almost granted that there will be an issues. So if you want to quickly make a lot of money from bug bounties, then start from that. Check the projects which don't have a tests, and if there are features that they have without test, it's a perfect place to start. Especially if those places are very dangerous, like virtual machine, transaction processing, cryptography, everything related to that. And write a good fuzzer, and probably you will find issues pretty quickly. This is also an important thing. If the project is not using all the tools for this testing, like they don't use fuzzing, they don't use some linter and other automated tools for finding bugs and issues quickly, this is a red flag, because those people don't really care about the security. This is how I see it. So yeah, I mean, for example, this is from what I remember, how I found the bug in the Binance zero knowledge proof circuit implementation. They were using this pretty complex code, and I managed to find a scenario which didn't validate one of the values correctly, which led to integer overflow, and it was allowing to create a fake proof. But I won't be talking about this issue. There's an article on the Hacken website, Hacken blog, and from what I remember, there are some talks about this on the YouTube. I was doing this presentation like 2 or 3 times. So if you enter Bartosz Barwikowski, Binance, then you will find it. Bartosz Barwikowski, Binance, proof of reserves. So it was very, very interesting issue, and it was the only issue which I found in zero knowledge proof, because I don't have too much experience with zero knowledge proof. I worked. It was my first. It wasn't an audit. I mean, it was like a challenge. I mean, they published this zero knowledge proof and system, and they made it open source. So I took the challenge to understand how it's working, and totally by chance I found the issue, and then I was able to find it because it wasn't super related to zero knowledge proof. It was like a classic coding issue. I mean, integer overflow. It's not like only for zero knowledge proof. So yeah, this is how my story with zero knowledge proof started. Okay, next part. Dangerous places in the code. So, for example, cryptography, randomness, oracles, serialization, everything related to transaction processing. So yeah, those are the places I always check, because it's again those are places where you really need to have the expert knowledge to use them correctly, because it's very easy to make a mistake. Like in cryptography, if you are using incorrect randomness, or if you are incorrectly calling functions, then it's going to be quickly critical issues. Or you can introduce a critical issue often with a single wrong line of the code. Like, for example, if you are going to use deterministic random number generator, where it can be, let's say, limited to, let's say, 1 billion possibilities, then, or if you are using current time to generate randomness or other similar thing, this is a very critical issues which normally you don't which you are not able to notice by yourself, or often even with the tools, because this requires this very deep knowledge about implementation, how it works. So those are the places which for sure require a lot of testing, especially fuzzing, because there are so many possibilities that you need to use fuzzing to uncover some of them. And I found 20 or 30 critical issues just with the fuzzing. So it's pretty great. And what else? And another important thing is that usually when you find an issue in this part of the code, it's usually critical issue by default, which allows to steal a lot of money. So if you are hunting for the critical issue, and I do mostly hunt for high severity and critical issues. I'm not really interested in medium or low severity issues. I'm aiming for the biggest ones, because in many cases or in many audits you have 50 low severity issues reported when someone made I don't know, spelling mistake, or didn't use the most optimal solution, or wrote too much code. And the thing is, those are super boring and basically useless, in my opinion. I mean, information like this, I would just say it's like a waste of time. So I only focus on those issues who are really important. So when you ever read a report from me, like on the Hacken webpage with all the reports, you won't find many medium or low severity issues, because in many cases, I don't even put them in the report. I just, eventually send them to the project directly if I see something, because it would be just a waste of time of the customer time, which he is paying for the audit to report such issues. So yeah, that's why I mostly focus on those places, because that's where the issue will be critical when there is an issue. So yeah, everything related to like places where the money are involved, or the tokens. Okay, for example, another example, how to easily make mistake is randomness. For example, this is an example in case of the smart contract. So let's say you have some smart contract which is using randomness, and it has two scenarios. Like let's say it's a roll the dice smart contract. You have two outcomes, like winning and losing. And for example, when you are winning, you are getting the tokens. When you are losing, the tokens are distributed to the liquidity pool. And even if your randomness implementation is perfect, even if it works correctly, then there are other ways to attack this smart contract. In this particular example, you can see that in case of the transaction where tokens are transferred to the winner, it would only consume 100 extra gas. But in case of losing a bet, it would consume 200 extra gas. So the way to abuse this mechanism would be just to limit the max transaction gas. So when your transaction is winning, the transaction will be completed correctly. But in case of the losing, there wouldn't be enough gas to complete the transaction. So, just with such simple mistake, it would be possible to like steal all the money from the smart contract if it had a logic like this. So yeah, this is what I mean, that doing anything with those functions like cryptography, randomness, oracles, serialization, and some other complex things like flash loans requires an expert knowledge in that field, because there are many traps which are hidden, and if you are not aware of them, you should not touch those features, because as you can see on this example, it's very easy to make a mistake. Okay, another example is with the cryptography, like when you are trying, for example, to generate some hash, and you are not aware that and you implemented it incorrectly, like you are using 3 different values, like information about key value, and you might end up in the situation where for 2 different like key and value pairs, you end up with the same hash, because they are implemented incorrectly when it comes to calculating this hash. So this is like a simple mistake. But the consequences of such mistake could be catastrophic. Like, for example, if this hash was used to like store the tokens or control the permissions, then maybe it would lead to finding a way to somehow abuse it. And from the practical examples, I've seen the bugs like this. I found the bugs like this in Merkle trees. Like in case of the Merkle tree, from what I remember, it was possible to like not guess exactly, but it was the Merkle tree was using the hashes as authentication method, and from what I remember, it was possible to like compute the correct hash to unlock the given airdrop by using like 4 hours of the computation on the GPU, because they had like limited number of possibilities due to some mistake in the hashing function. There was like they were using like four bytes of information of unique information per hash, and 4 bytes informations are like 4 billion different hashes, because it's 2 to the power to 32, and with a GPU you are able to like compute 1 million hashes per second. So within a few hours you were able to compute all the 4 billion hashes and find the correct one to unlock the Merkle tree. And the funny thing is, there's one more pretty interesting story. And actually, this was So there was a tournament when the task was to guess the seed phrase for a wallet. So there was a challenge, and the idea was that a fan page of a project will be posting 12 words to the seed phrase to the wallet in different places. So the task was, okay, on every social platform we have and some websites and some partner websites, we're gonna post somewhere one word for a seed phrase. And in the first day, we're gonna post 10 words, and the next day we're gonna post 2 words. And as you may probably guessed, the challenge ended up in the first day, after someone was able to find 9 words, because it was possible to easily compute the other words, because when you have 9 out of 12 words for a seed phrase, then you have only 2000 to the power of 3 combinations for other words, because for single word there are like 2048 combinations. So you multiple, you have this 3 missing words. It gives you, I think, 4 billion combinations. Let me check. No, a little bit more. Let's see. 8.5 billion combinations. So this is something one can be computed in like 4 hours, and maybe I still have the code to that program which was doing that. Let's see. If I can find it in the 30 seconds, I will even post it, because it will be funny. What was the name of the guy? I don't remember this. Shit, Stefan. Okay, one of my weaknesses is that I don't remember the names. But anyway, even if you write to the ChatGPT, Gemini, or Grok to write to a program that you have 9 words from the seed phrase, and you need a program to check all other words which are possible to find the wallet, it will write it for you. So it's not like some magic. But yeah, a mistake like this can be pretty painful. So yeah, keep it in mind. Okay, next thing, top 3. So also amazing one, mostly applying to smart contracts, but not only. And those are the multi-step operations and multi-transactions. So sometimes you have to do something, you need to complete like few transactions. For example, in the lending protocol, you have to like first create a loan, then deposit tokens, then borrow tokens, then you have cases where the loan can be liquidated, There can be you can withdraw part of the deposit, stuff like that, and you know, when you have all of that, then there's I'm gonna say it a lot. It's very easy to make a mistake because a lot can happen between those steps. Like this is actually the case which I was presenting like this 2 or 3 weeks ago on my webinar when I was working with the lending protocol, and I've seen that they have very complex multi-step operations. You know, to close the loan, you had like to have 5 different operations in the transactions. And the thing is that you can do everything you want between those steps. You can like do them in the incorrect order. You can start a flash loan. You can increase debt when you are liquidating the loan, stuff like this. There are like huge number of possible edge cases and scenarios, and in many cases the developers don't think about them, or only some of them. So you know, with every next step the logic is increasing by a lot, exponentially. Yeah, that's the word what I was looking for. So it's very easy to make a mistake, especially when you combine it with some dangerous things like flash loans. So when I see some operation which requires multiple steps in the correct order, and there's no validation that the order is correct, then you know it's a huge red flag, and for sure I will be checking the code like this. So I mean, in my case, I'm using the approach keep it simple, stupid case, and I try to use this atomic behavior of transactions operations. So yeah, that's it. Oh yeah, I even have this example. Like for example, this which I was talking about 2 or 3 weeks ago. They had this Weft Finance. They had this very complex liquidation mechanism when they were, doing this liquidation process in a few different calls to the smart contracts in a single transactions, and by changing like the owner of the loan and taking more debt during this liquidation, I was able to basically cheat the system and generate free loans because I was abusing this liquidation mechanism. But you know, if you want to check more, there's a blog on the Hacken. There's a post on the Hacken blog and the webinar from 2 weeks or 3 weeks ago. It should be on YouTube or somewhere. Okay, so let's skip this part. Okay, top 2, and it's I love that, you know, reinventing the wheel. And by this I mean coding something that shouldn't be coded. So you know, sometimes you have developers or which really like to do everything by themselves. Like they use those, create the custom frameworks for everything, custom functions. They don't trust the other projects. I mean, I was like that, but you know, it was 10 or 8 years ago. And then I learned that maybe it's not the best approach to do everything by myself, because first of all, I waste a lot of time. And second of all, usually it wasn't better. So yeah, so this is a huge red flag. So when I see something like someone is starting to write their own serialization, cryptography, virtual machine, or like P2P protocols, which like require very complex knowledge, an expert knowledge. It takes a lot of time to like audit, validate, test all of those things, and usually it costs like huge amount of money to build them. This is a huge red flag, especially that there are often ready to use the solutions, and yeah, when I see a project which is a developer who's trying to do stuff like this, I'm like 90% sure there's gonna be an issue. I mean, there's no way to build some things without making an issue. Like every blockchain protocol, seriously, every of them, Bitcoin, Ethereum, Solana, Sui, Aptos, all of them had a critical issues because those projects are so hard to build, they are so complex that that you just don't do that. I mean, if you don't have like 10 or 100 million dollars budget for development, you never touch parts. You never do stuff like doing complex features, which are like cryptography or virtual machines or P2P peer-to-peer protocols by yourself. You just don't do it. So if you see a project which is doing something like this, and they don't have like more than $10 million when it comes to the budget, as I say, I'm 90% sure that there will be an issues. And if you combine it with like other red flags, like if they don't have tests, it's like 99% that there will be an issue. So I love such projects, and I made a lot of money on that. And and this is also what AI is often doing. AI is often trying to implement something itself, which is terrible. But for me, it's perfect because it's almost guaranteed that there will be an issues. Okay, and I even have some example in this. Let me check this one. I think I talked enough about this case. Let's go to the top one. And the top one, oh my God, this is what I would say I'm specializing in. Those are the economic attacks, because those things which I was talking about, there are many of them which already required an expert knowledge. So out of projects, okay, serious projects. Serious projects are usually aware of this. So when they're having this complex code, and they know that they have to do an audit. They go to the auditors, to experienced software developers, to cybersecurity specialists, and they audit all the code and everything what they created, which is already expensive, hard, and requires expert knowledge. But even if you do all of that, even if you didn't make any of the previous mistakes, like let's assume you have everything perfect, even if you did an audit, there's the last kind of the issues which usually apply only to Web3 projects. Okay, mostly to Web3 projects, which are actually the hardest to find. And those are the economic attacks. So even if your code is perfect, you have like everything tested, you have like no bugs, then you still can have issues when it comes to your business or economic model. For example, you're allowing to have too high leverage, or you don't assuming that the value of assets can change correctly, or you configured something incorrectly after deployment. Those are the things which are usually not checked during the audits, because those require actually real world scenarios. I mean, usually when the code is audited, it's not code which is already released on the mainnet. I mean, what would be the point, right? And usually the people don't pay for a second audit when something is already released. So when you have this code which is already released, it's already configured, then it's a moment when economic attacks are starting to be possible. And for example, let me give you an example with a lending protocol. Let's say you have this lending protocol which allows you to borrow USDC or Ethereum and you can use any asset to as collateral. So you put this, let's say, Pepe coin, which is worth like nothing. The owners of this lending platform are aware of this, so they are using only this 20% loan to value ratio, which means that, okay, if I deposit $100 in Pepe coin as collateral, then I can only borrow $20 of USDC. But the thing is, this is still not enough, because what's important is liquidity of this Pepe coin. And in this imaginary scenario, it's fake. It's very low. So like the whole liquidity is based on, I don't know, let's say $5,000. So it means that by spending $5,000, I would basically move the price of the Pepe coin 10 times up. So it's a perfect attack scenario. Let's say an attacker uses 20K to buy. Okay, I use the frogs, but so let's use the frogs in this example. So, but it's the same as this Pepe. Okay, so let's say attacker uses this 20K to buy all the frogs from the market, and he's able to buy like 10 million of them. And the price, because he bought like everything what was available, jumps from 0.1 cent to 10 cents. So increases by 100 times. And and because of this, he spent $20,000, and now he has the coins, which in theory are worth $1 million. And now you can use this 10 million frogs tokens to use as the collateral, which by the platform will be calculated that it's worth $1 million, and it would allow you to borrow $200,000. So you just use the tokens as collateral, and you get $180,000 profit after that. And there were attacks like this. I mean, there was a case of this guy. I'm really bad at remembering names. It was something with OrangeFi. There was a guy who did something like this on real platform. He stole like $100 million with doing something like this. But he was stupid, from what I remember, and he posted about this on Twitter and was jailed for like 10 years. But from what I heard, later he was like released from those charges. The charges were dropped, but he was sentenced for something else. OrangeFi, was it called? OrangeFi. I don't remember. But if you search for this lending platform, $100 million. Okay, I will find it for you. Give me. We have time. We are almost, finishing. So you can start to ask the questions on the chat, because I will be answering them in like 2 minutes. But let me check. What was this guy called? Orange lending still. I will ask AI. Okay, let's see. ChatGPT, please help me. I'm using AI a lot. Mango Markets. Oh, Jesus, I'm not able to spell his name. Harham Eisenberg? Okay, anyway, it's called 2022 Mango Market Exploit. So, this is a real case, and you can read about this. And this is like the most favorite kind of issues, because those issues are usually not detected during the audits. they require like another very they require another expertise in another field, so like economics. So usually auditors don't have them. Auditors are usually experienced with programming, cybersecurity. But here's is totally different. For this, you need a guy who will open the Excel and calculate if there's a way to somehow abuse the tokenomics or like the mechanism they have. You need to calculate like probability and some other stuff. And it so happens that I'm this kind of the guy. So, I often, when I see a case like this, I will open the Excel, I will calculate if something is worth it, what is the risk to reward ratio, and it allows me to find the very interesting issues like this, which, to be honest, in many cases are legal because but it's a tricky topic. It depends, which, to be honest, I don't know much about. Maybe I know something about cybersecurity and tokenomics and economics, but when it comes to the legal stuff, I don't know much. So I won't be, suggesting anything. Oh yeah, and yeah, there is even last page. I forgot about this. So yeah, and still the most important thing is, of course, combining it all together. It's not like you will use one approach and it will be the most effective one. You can just use it all the times. No, of course, you need to combine everything together. So you often need to connect the dots between one issue to another, and it allows you to unlock even more potential issues. So yeah, I mean, if you want to see us in action at Hacken, get an audit, let us find some issues for you. You can, visit our website, hacken.io. Hacken is also having this amazing bug bounty platform, Hacken Proof. So, even if you already did the audit, I really recommend to have a bug bounty program. So when I find an issue, which I was, similar issues to which I was describing today, I can report it to you. Yeah, and everyone will be satisfied. Then the bug bounty is the best approach. So it's a must-have if you have a Web3 project. If you don't have, then try to find out why the other protocols which didn't have them right now, because there were many projects like this who didn't think they need bug bounty, but for some reason they're on Hacken Proof right now. And there's one very cool thing when it comes to audits with Hacken. Right now we have this dual defense approach, which is basically after the audit, the Hacken is doing the bug bounty for third-party auditors. So Hacken is doing an audit, and after the audit, there's 30-day dual defense pool, which is like a bug bounty. If some other auditor or Hacken can find the critical issue which Hacken missed, then he will just get the money of the audit. Long story short, if Hacken misses the issues, then we'll pay that money to bug hunter who finds it. So yeah, it's an amazing deal, which and it's not. And there even were cases like this. There was, because it always happened. One, you cannot find all the issues. I also missed an issue in my career, and it's a normal thing. And like one time for like 20 audits, there was a case where we missed an issue, but the bug hunter found it and he got the money. Everybody was happy in the end. And the customer didn't pay anything extra for the output because it was included. So that's a pretty cool stuff. Okay, now I will answer some questions. Let's see. We have a question. What if you had all 24 words to a seed phrase? How fast could you hack the wallet? I mean, it depends, because if I had all the words, then all I have to do is just like enter them in my application, and that's basically it. So yeah, so like 30 seconds. But there may be a different case, like, okay, what if I have the 24 words, but but I don't know the order? What is the correct order? This is a harder question, because then it's, oh well, I don't know the English word for that. Give me a second. I need to check the word. Factorial, because it will be 24 factorial. So it's like 24 times 23 times 22 times 21 number of the combinations. So let's see how much it is. Well, it's a lot. It's impossible to compute what would be the final seed phrase, because the number of combination is huge. It's like a 10 to the power to 23. So it's just impossible to compute. Okay, maybe it would be possible, but it would cost like $1 million probably to compute it. So not worth it. But in case of 12 words, it would be much easier. In case of 12 words, you can check every combination in an hour easily. So maybe that may be a reason why they use 24. So yeah, I didn't think about that because, to be honest, I don't know the technical details about this. But yeah, that's interesting one. Okay, another question. You made a custom-built AI agent that was tailored specifically for Quan. Are you planning to make this custom-built AI agent to other protocols? Okay, so this AI tool, it was pretty cool. This is the first time we built such advanced tool for a layer 1 audit. So I was doing an audit of the Quan protocol, like their execution. I was checking their execution environment for non-determinism, which is like quite important thing in case of the blockchain. But the problem was that the code base was huge, and testing everything manually would take a lot of time, and it would be very easy to miss some issues. So I had this idea that with all the AI tools which we have right now, we can use this to like test every possible scenario for potential non-determinism, because it's not like because there was like limited number of scenarios. There was, I don't know, 100 different categories of non-determinism. So I decided to build such tool, which was using AI to basically test every possible category of non-determinism. And it created 2,800 tests, which were able to identify 22 ways to cause the non-determinism in the project, which was a major success in my opinion. And later, the Quant platform team managed to fix all the issues, and we retested the project again with all the tests, with all the tools we had, and I confirmed that all the non-deterministic issues which we found were fixed, which was another great success. But the thing is, when it comes to this AI tool, it was mostly designed for the Quant protocol. It can be adapted to other projects, because it has this approach where it's having the 3 different steps. Like the first step is to create plans, what to test and how to test them. Then in the second step, it's writing those tests, correcting them, executing them, and if everything is working, then it's trying to change them. So there are some issues. And if it fails after a few tries, then the test is done, and it goes to another one. And you can like use an AI model for that you want. And the third step is like summarizing everything and writing a final report. So this approach is, I would say, generic, but it needs to be like configured for each project separately, because each project is different. So it can be used enough for different projects, but it just requires 20 hours of work of an experienced auditor or software engineer. So at this moment I don't plan to port them for other projects. Probably, if we port them or apply to the other protocols, it will be during the audit of some project. So, if we have some client for a layer 1 audit or some other audit of complex platform, we will use this tool for them if it's applicable and possible to do it. I mean, you can also do it yourself. It's up to you. It's open source. So no plans for like the next 2 months. It will be, it will depend on the clients. Okay, can we talk about Quan QVM audit later? I mean, I talked about this in the previous question. I mean, it was very interesting audit. This AI tool was paid for this. It worked pretty well. Oh, I didn't know. I can click on the question and it appears on the screen. I wanted to copy this because I don't understand and I need to translate it. I'm from the Poland, so I don't know Cyrillica. Let's say Natalia Budorina Stielat Riepost Stoi. Okay, I don't understand. How can I copy it? Okay, wait, I will just translate it. Okay, so it was the comment that she reposted this this broadcast. It wasn't the question. Okay, next question. Your AI test also wallet implementation code or specific programming language? In case of the Quan, it's testing their virtual machine implementation, but it can be applied to the other projects. It doesn't test anything else. It's mostly designed for testing virtual machines, so it's rather not applicable to wallet. It's more for scenarios where you have a code and you can easily test it. Okay, let's go. This was the last one. So no, the same answer. It's more for the virtual machines and execution environments for the smart contracts. Okay, there are no more questions. I hope you enjoyed it, and I invite you to follow me on Twitter and follow Hacken and Hacken Proof. I sometimes post. I work a lot with AI right now, so I post some interesting tools I'm building, and when I have some good issues found in Web3 projects, I also post about them. So I think it's pretty cool to follow it, so I really recommend to do it. And that's all for today. Thank you for watching this webinar. I really hope you enjoyed it. And if you are interested in next webinars, then let me know. I think I can prepare something cool, maybe something about AI agents. So I'm looking forward to your feedback on Twitter, LinkedIn, and maybe YouTube if someone is watching this on YouTube. So yeah, I wish you all a great day, and see you next time. Bye. I should end the transmission. Okay, end stream.